Hello everyone. Today let us solve the problem linked list random node. Given a singly linked list, return a random node's value from the linked list. Each node must have the same probability of being chosen. Implement the solution class. Solution list node head initializes the object with the head of the singly linked list. Int getRandom method chooses a node randomly from the list and returns its value. All the nodes of the list should be equally likely to be chosen. Okay. So we have a linked list, say 1, 2, 3, 4 and 5. Okay. Whenever we call our getRandom method, one of the node's node values has to be returned and each node must have the same probability to be chosen. Okay. So if we consider the probabilities of each of the nodes, what is it going to be? How many nodes do we have? We have 5 nodes. That is, the total probability is 1, that is 5 by 5. To choose this node, the probability is 1 by 5. To choose this one, it's 1 by 5. This one is 1 by 5. This one is 1 by 5. And this one is 1 by 5. That is what means by equally likely, isn't it? So what are we going to do? If we think about the naive approach, okay, first of all, we know that in every programming language we have a random inbuilt function, right, which can generate random numbers. Okay, we are going to use this. Now in the naive approach, what we can do is we can convert this linked list into a list, okay, which will have indexing, isn't it? Because in this one we don't have indexing, so it's kind of difficult to choose from them, right? So we'll convert them to a list. Let's say this is our list 1 2 3 4 and 5. Now we will generate a random index. How do we generate a random index? In Java, if we use the random function, it's going to return us a random number between 0 to 1, exclusive. Okay, that is till 0.99999 like that. Okay, never 1. So if we multiply this, whatever is, suppose we get a probability of 0.5. Okay, if we multiply this into the length, okay, let's say our length is 5. Okay, what is the probability going to be? What is the index going to be? It's going to be 0.5 into length, 5 into 0.5, that is 2.5, which is nothing but index 2. If we convert it back to an integer, it's going to be index 2. So we are going to return this 0 1 2. Let's say our random function returns us a let's say 0.7, let's say. So 0.7 into 5 is 3.5. So we are going to return index 3 if we convert it to an integer. Okay, so that's what we are going to do. Simple approach. Let's see the code. So this is the code. Globally we declare our array list, okay, and here we initialize it, okay, in our constructor. So while our head is not null, we add each of the integer values, node values, to our list. Okay, then whenever our getRandom function is called, we generate a random index. Okay, that's exactly what we did. Math.random, the number would be between 0 to 1. Okay, exclusive, inclusive, into list size, convert it to a int, we get the index, and return list.get random index. Okay, so this is the simple approach. What is the time complexity? This uh, method, this constructor is going to be called only once, so that is a big O of n. Okay, but this getRandom method can be called a lot of times, right? As many as 10 power 4 or 5 times, as mentioned in the question. So let's say it's called, let's say, k times. Okay, k times. So our time complexity is going to be big O of n plus k. The n to add the values into our list, and k, that is the number of calls. Okay, now what about the space complexity? We are using an extra space, right? We are creating this list, that is a big O of n. Okay, so this is the naive approach. Now what if we try to space optimize our approach? We can't use a list, right? We can't use a list. In that case, we can't use the help of indexing. So in such a case, what are we supposed to do? We will definitely generate a random index, right? A random index. Now if we can't access that random index, what else can we do? We will have to reach to that, we have to iterate up to that index, isn't it? That, okay, we don't have a list, so we can't access it. So if we have an index and we want that value in that particular index, there is no other way than to serially go through the linked list, right, up to that index. Let's say the random generated index is this one, then we have to iterate through the list and reach up to here, then only we can access it, isn't it? So this is also a possible solution. Okay, so this is how the solution is gonna look like. Globally we will have the length of the linked list, and globally we will have a reference to the head of our linked list. Okay, So in our constructor we will compute the length. Okay, we will compute the length. Okay, fine. Now in our get random we will generate the random index. How? Just the way before, right? Math.random into length. Now we had our length here, right, globally, so we can access it, and we will start iterating from the head. Okay, we'll start iterating from the head, and initially our index is 0. So while our index is not equal to the random index that we generated, we will keep moving forward. Okay, and we will increment our index, and finally when we reach it, right, it will become equals to random index, right? So in that case our while loop will break and we will finally return the value. Okay, pretty simple, right? Now what is the time complexity? So our solution constructor is taking a time of big O of n, isn't it? And our get random method is taking a time of big O of n now. In the previous solution it was taking a big O of 1 time, isn't it? But since we are making k calls, we assumed we are making k calls, so it became k. Now since it's taking big O of n time and we assume that we are making k calls, so our get random method is going to be big O of n into k, right? So our total time complexity is going to be big O of n plus n into k, which is simplified, it's n into k only. And our space complexity is this time constant. We haven't used any extra space. Okay, so that's all from my side. We can also use an algorithm called reservoir sampling. Reservoir sampling. Okay, but that would be another big O of n into k algorithm. The last one that we saw was also big O of n into k, right? And the first one that we saw was big O of n plus k, right? But it used a big O of n space, isn't it? So time complexity wise, I feel that the first one is the better one. Okay, so yeah, it's totally your call. Okay, so if you like this video, do hit the like button, share this video and subscribe to my channel, and I will see you in the next video. Bye bye.